tutorial for the Newton's Laws exam. This question is involving a cart. The cart is being pushed with a force of 500 newtons and it has a friction of negative 500 newtons. The equations that are pertaining to this unit are the sum of the forces is equal to mass times acceleration. If you rearrange it, you get acceleration is equal to the net force over the mass. Sum of the forces and net force are the same thing, just two different ways to write it. The other equation that we deal with is weight, and weight is equal to the force of gravity, which is equal to mass times the gravitational constant, which is g, which is of course negative 9.8 newtons per kilogram. The first question says draw the force diagram of the cart above, so we're going to draw it around this dot, show the actual numbers and magnitudes of the forces, and explain the difference between mass and weight. So the first thing we know is that there is 500 newtons going to the right, and so we're going to draw an arrow to the right, and that is what we call an applied force. And in this case, the applied force is actually equal to 500 newtons. So when we are going to balance this, if this was a dot in space, this would be accelerating to the right because there's nothing balancing it. So if you see here, there is something balancing it over here. So this is the force of friction. And this arrow that we use has to be the same size in the opposite direction. So that will balance out, so it's not going to move. So the force of friction, in this case, is going to be a negative 500 newtons. And so looking at this, it's balanced. It's not going to accelerate. It might be moving, it might not be moving. We'll talk about that more in question 2. The other things we have on it is we have a downward force, of course, because that downward force is the force of gravity. So when we do this, the force of gravity is going to be equal to your weight. Your weight is the force of gravity. It's mass times gravity. So at this point, it's probably a good idea to start talking about the difference between mass and weight. So mass is the amount of matter in an object. It's the same everywhere, and it's measured in kilograms. The mass of the cart above is 1,000 kilograms. On the other hand, weight can change depending on location. So weight is the force of gravity acting on a mass. Weight is equal to the force of gravity, which is equal to mass times gravity. It can change depending on location. Weight is measured in newtons. The weight of the cart is 9,800 newtons. So when we do this, we would say the force of gravity equals mass times gravity, which equals to 1,000 times, actually negative 9.8, and that's going to give us our total. And so that's why the force of gravity equals negative 9,800 newtons. Now, once again, if we looked at this, we would think that this thing was accelerating downward, and it can't be. So we have to have a force going up to counteract that, and of course it's on the ground. So the ground or any surface, we call that the normal force. And the normal force has to be the same size as the force down in order to balance it out. So in this case, we can see that there is no acceleration going on, which gives us to our next equation. This question, it says, can you say for certain whether the object is moving or not moving or accelerating? When I look at this, I can't tell by looking, so I need some clues. Choose the Newton's law that applies to this question and explain your answer. So we got going on here is Newton's second law says an object will not change velocity. It will not accelerate unless it's acted upon by unbalanced forces. And we already said these are balanced. Since all these forces are balanced and the net force is 0, we can say it will not accelerate. This means if it is in motion, it will stay in motion. If it is not in motion, it will stay not in motion. What that brings us to is just a simple question. By looking at it, can you tell what velocity is? We don't know if it is moving or not. All we do know is that the acceleration is 0. So I will explain the remainder of the questions in the next video segment.